Hi guys, tonight for homework you're going to be watching a video of the notes for section 6.3. So please take your yellow packet, open it up, and go to page 6. We're going to start talking about similar polygons in class, and this will help us get through a lot more practice in your groups. So the first thing that I would like you to do is draw two similar polygons. Similar polygons has to be two shapes that have the same shape, but they have proportional sides. So one example of that could be a random quadrilateral that is going to go like this. And then what I want you to do is draw a bigger one, keeping kind of the same shape. Let's call this one A, B, C, D, and this one E, F, G, H. So what we have here is two similar, the symbol for similar is just the little tilde or squiggly, of similar polygons. So for this, angle B is congruent to angle F, C is congruent to G, D is congruent to H, and A is congruent to E. We're going to make a list of all of the congruent angles. So angle B congruent to F, C congruent to G, D congruent to H, and A congruent to E. So whenever you have similar polygons, the angles must be congruent. Sides proportional means that if I was to divide whatever the length of AB is and divide it by the length of FE, that would give me the same ratio as dividing BC over FG. So here's the following proportion that must be true. AB divided by FE has to be equal to BC divided by FG has to be the same as CD divided by GH, and it has to be the same as AD divided by EH. In the next example, what I would like you guys to do on your own is list the pair of congruent angles and then write the ratio of corresponding sides. So basically, you're listing all of the corresponding sides, JK over ST, KL over TU, and so on, going around this pentagon. This is called a similarity statement, and it tells you that with the little similarity symbol, JKLMN is similar to STUVW. So why don't you pause the video now and please finish example 1. The scale factor of two similar shapes is basically a comparison of their sides. If two polygons are similar, then the scale factor will be simply, if I have a rectangle that's 3 by 2, and then I know another similar rectangle is 6 by 4, the scale factor would be 3 over 6, which is exactly the same as 2 over 4. The scale factor is the reduced ratio of 1/2. This is the scale factor for those two rectangles that I drew. So for example 2, we have to find the scale factor. First of all, we need to decide whether the two figures are similar. So one way to check for that is to have all of the angles congruent. So now 2 arcs, a right angle, these are congruent. Yes, check. Those angles are congruent. Now the next thing we need to check is to see if we have a scale factor or if we compare the sides and they end up being the same fraction like they did over here for the two rectangles in the definition. So I'm going to compare 15 over, now XW goes with QP. So 15 divided by 10 is the same as 6 over 4, because XY and QR go together. Now is that going to be the same as 9 over 6? And then is that going to be the same as 12 over 8? Now, using your calculator, if you were to reduce 15 over 10, 6 over 4, 9 over 6, 12 over 8, all of those reduce to 3 over 2. And this is the scale factor between those two quadrilaterals. What I would like you to do for the example 3 is please tell me what sides correspond to each other. So like DE has to be proportional to MN. I'm going to use that 9 over 12, which is essentially, if I know that these two are similar, 9 over 12, that's going to be the same as the reduced fraction, which is the scale factor. And now I'm going to set it equal to x over 20, because this side over this side should be the same as this side over this side, since the two triangles are similar. Now what you have to do is cross multiply and solve for x. Why don't you guys do that using your calculators? If you did it correctly, x is equal to 15. In the next example, the same idea is given, that ABCD is similar to QRST. 10 goes with 5, 12 corresponds to 6, x corresponds to 4, 16 corresponds to 8. You can use any of the given sides to write your scale factor, like I did over here, and then you can find x. Why don't you pause the video and try it? I'm going to give you the final answer in a second. Hopefully you get the answer correctly. If you solve this correctly, x should be 8. Make sure that when I'm checking your homework, you actually show me work how you figure that out. The scale factor for this, if we compare and we actually check for all of them, 10 over 5, 12 over 6, 16 over 8, 8 over 4, it reduces to 2 to 1. What is the scale factor of QRST to ABCD? The final answer should actually be 1 over 2, because we're comparing the smaller one to the bigger one. One more idea about, actually, let's stop. Hopefully you guys listened. We will finish the rest of the notes in class. Thank you for doing your homework. Make sure you actually understand this. Don't just copy the video without understanding the material. I will give you a very short 3-question mini quiz on these notes. So please make sure you understand what you're doing. Thanks guys, and see you tomorrow.